Hi all, welcome back to our YouTube channel. I hope you are all are doing well. And topic that we have today is efficient frontier. Yeah, but before we go ahead, please do subscribe to our YouTube channel. And at our institute, we stimulate your thought process to enhance learning. So we prefer quality over quantity. So please do subscribe to our channel. It takes a lot of efforts to come up with videos like this. So yeah, this topic is basically in paper 4 as well as in paper 1, that is in valuation and risk models as well as in foundation of risk management. So slightly there is a overlap between both papers, but yeah, the fundamentals will remain same. So topic that we have today is efficient frontier. So it's basically from modern portfolio theory, wherein if I were to tell you a problem statement, let me just put problem statement in front of you. Say, for example, you have to invest, say, $100, just for sake of understanding, and you have two stocks, X and Y. So now, what should be your weight? Out of 100, how much you should allocate to X and how much you should allocate to Y. So that's where efficient frontier comes into the picture. So efficient frontier helps you allocating appropriate weights. Okay, so see, you might be finding it a bit abstract. I'll just demonstrate using the practical examples. But from this graph also, if you see that these are various portfolio, I mean, you can just think of, say, A could be portfolio wherein X and Y could have 50% and 50%. Okay, and portfolio B could be, there could be varying weights. So these portfolios were constructed, and like this graph was plotted against it could be standard deviation versus returns or variance versus returns, so it's fine. So it's mainly risk versus returns portfolio. So you notice that at B the x coordinate is 2%. So if I were to plot this, there is a 2% variance of this, whereas if you notice the y coordinate, it's 4%. So return is 4% at 2% risk. D is also having a 2% risk, but it is giving you a 8% return. So return is 8% at variance of 2%. In portfolio B, returns are 4% with the variance of 2%. So the what efficient frontier tells you, this portion, basically the black portion in the efficient frontier is inefficient, and other way to say that this blue portion is efficient one. It will give you the same amount of returns at a it will give you higher amount of returns at the same level of risk. So that's where this efficient frontier tells you. So yeah, it represents the blue curve passing through these portfolios C, D, E, F, G, and so basically all the investors try to be rational. They they want to have the lower risk and higher returns. So that's where this efficient frontier comes into the picture. Now let's demonstrate using the most interesting part. So stay till end. The part that I'll be showing you now might excite you more. So the practical one. So let's have a look. Just give me a moment. Let me open my Excel. So here are two stocks that we have chosen randomly. So the one is Ambuja Cement and other is Godrej Properties. So more or less from real estate related stocks. So these are the monthly stock prices from last year, from September 2022 till August 2023. So corresponding monthly prices are given over here. So what we'll do, we will try to build a portfolio using these two stocks. So we will allocate some weight initially in Ambuja Cement and in Gojek Properties. We'll try to calculate what is portfolio return and what is portfolio risk. So to calculate this portfolio returns, we will use this formula, which is kind of very intuitive. Uh, it's a weighted average. So like weight of Ambuja Cement, weight of Godrej, and expected return of Ambuja Cement and expected returns of Godrej Properties. So that's will give you the expected return of portfolio. Similarly, with the same convention, we can have standard deviation also. W1 square, sigma 1 square, like where W2 square, sigma 2 square. Two times, it's like two times correlation. So additional factor, you need to take care into account the correlation, because for negatively correlated stock, you get a diversification benefit. So that's where correlation plays an important role. So I'll not go into detail of how it would be for n stocks. Currently, we have two stocks for our analysis. So we will consider this formula. So before I start, let's assume that initially you put complete into 100% into Ambuja Cement and 0% in Godrej Properties. Then what you do, you put 99% in Ambuja Cement and you increase that 1% remaining, you allocate that to Godrej Properties. So I'll just add this 1% in this. Likewise, we can go till all the way wherein you have complete 100% in Godrej Properties and 0% in Ambuja Cement. So I'll just do I'll just drag these formulas to just a minute. I think there is something wrong. So this minus 1%, this plus 1%. Okay, yeah. Let me just come up till 103. So yeah, you can see over here now it's 0 in Ambuja Cement and 100% in Godrej Properties. So we are not recommending anything. Wait, please note important. Uh, this is just for understanding. No recommendation or any commentary, official commentary. Very important to make a note of. So let's see. Yeah. Now what we'll do, we'll calculate portfolio returns. So which is weight one into returns of Ambuja Cement. So let's calculate first returns of Ambuja Cement. Let me just wrap these up. Yeah, so let's calculate returns. Just pull it there. Now we have, let's calculate returns over here, then we'll calculate average. First of all, we need to calculate return, and for returns, I will use the simple formula. Your returns are equal to final price minus initial price divided by your initial price. So in this case, we will start from a second row, because for first row, we don't have any data where there is no initial price before September 1. Of course, there will be, but in our data, it's not there. So we'll start from second point, and don't forget to put the bracket. Otherwise, because of BODMAS thing, your calculation will not be correct. So final price October, initial price September divided by your initial price. So that gives you around 3.37%. I'll just paste this formula to calculate. This is a Godrej. I might have performed some other analysis as well. So that's why it's showing Maruti. So Godrej. I'll just drag these formulas, and yeah, these are our data points. Now what I'll do, I'll just calculate average returns. So these are uh, monthly data points for a year. I'll calculate what is this average of this. So negative returns because of some XYZ reason. Godrej Property, some 3% returns. I'll calculate standard deviation as well. So I'll just calculate standard deviation. So standard deviation of this data points around 9.77%. And one more factor we need to calculate standard deviation, which we saw, that was correlation. Correlation basically tells you how stocks are linearly moving in the same direction. So these are two arrays, returns of Ambuja and returns of Godrej. So there is significant correlation. It's around 47%. So let me just put it in a decimals. So now we have got sufficient data to calculate portfolio risk and returns and then plot our efficient frontier. So let's calculate returns first. So returns are basically weighted average. So weight of Ambuja cement is this, returns of Ambuja cement is this, plus weight of Godrej into returns of Godrej. So this is my portfolio return when I invest 100% in Ambuja and Godrej point 0 in Godrej. So important point to note over here is because we have invested 0 in Godrej, complete data of Ambuja will be reflected. So you can see a negative 0.14% and negative 0.14% here. Now bit tricky formula, be careful. So I'll just put first square root. Now I'm calculating standard deviation of portfolio. So square root of weight 1 square, that is 100 square, into standard deviation of Ambuja square plus weight of Godrej square plus standard deviation of Godrej square. Initially it was Ambuja, my bad, but yeah, it was put in correctly. So W1 square, sigma 1 square, W2 square, sigma 2 square plus 2 into correlation times your weight 1 into sigma 1, sorry, weight 1 into weight 2. It's a multiplication, so it's fine, A into B or B into A. So weight 1, weight 2 into sigma 1 into sigma 2. I'll just close bracket. And if you notice, the standard deviation is also matching with standard deviation of returns of Ambuja cement, because we have invested completely in Ambuja cement and nothing in Godrej cement. So let me just freeze the returns and standard deviation of stock so that I can drag the formula. So I logged it D and E. In this also we'll do same. We'll just keep H and I variable and we'll freeze D and E. So D also here. HI variable, again D fixed and E fixed. Once this is done, we are ready to drag the formula. So formula I dragged, and if you notice over here, the returns of, I think there is something wrong. Let me check. We might have not logged something. Just allow me a moment. I think there is something wrong. H2, D2, fine. And I see over here it's problem. I2 square into E2 square. Now I think it should be good. Let's see. Yeah. So if you notice now, it's matching with returns and standard deviation of Godrej properties when we invest 0 in Ambuja and 100% in Godrej properties. So returns and standard deviations are matching with these Godrej properties, 2.61 and 10.47. Let me just do some formatting to make it look good. Better. me just border it and round it off till second decimal. Looks better now. Key parameters. So similarly, we'll do here. Let me first do this data. Okay. Let me just delete these also, but make a note of it. That's not any recommendation of stock, just for understanding purpose. Okay, yeah. Now we'll just we'll put scattered plot to understand it better. Let me just put it over here. Let's keep it away. Otherwise, picking up data randomly. We need a blank scattered plot so that we can manually punch in data. So I need to plot. So let me just first name this efficient frontier. Now we'll punch in data. So let's put risk on x-axis. So again, it's asking for a name. Now let's put data risk on x-axis and returns on y-axis. So let's plot. Let's see if we have got something. Yeah, looks better. Let me just rescale this axis because it's not, you might not be finding it what we saw on slide. So let me just rescale this. Yeah, now it looks like a book. And let me rename axis titles. So let me just do this as returns. And this one is risk. So basically, if you notice that over here, its risk is 8.71, standard deviation is 6.71, and returns is 1.32. Similarly, you will notice another portfolio, 8.71 somewhere here. Let me just go down 8.7, yeah, 8.71. Yeah, the returns are 79%. So there is at the top, there is one more portfolio wherein it's what 0.32%. So 0.8% versus approximately 0.8% versus 0.132%. So the portfolio at this end is efficient. The one above this point. So this point is efficient for you. The one that is at the tangent at this. So what would be point? This would be a point wherein you have the lowest risk at a higher return. So 8.65. So there will be no portfolio which will have uh, risk lower than this, but returns higher than this. So yeah, this is a portfolio which we are looking for. So 8.65 and 1.01 is portfolio that we are looking for. So you will see that over here risk is increasing, return is decreasing. Yeah, 8.65 and 101. It's a bit tricky. I mean, because of if you remove mouse from this, so that data is lost. But yeah, 8.66, it's 0.99. Let's see if there is any other portfolio at 8.66. No. At, let me just check, 8.67. 8.67. 8.67. There are two portfolios. It's 0.9 and it's 1.21. So 8.67. There are two portfolios. At 8.66, it's 1.13, and 8.65, it's 1.04. So let's look at the data in if there are any portfolio. 8.66, yeah, there are two portfolios at 8.66 as well. We can verify it in data also. So the efficient one would be the one which is at, let me just verify. I think I noticed that there were two portfolios at 8.66. So 8.8, why it's showing an error? Flow risk. Something wrong. Let me have a look. Yeah, there are, I think the filter was not correct. So 8.66, there are many portfolios. So we'll notice that at 8.65 there would be only one. There are many at 8.65 also, but the returns with higher returns there would be only one. That's this one. So just increase the number of decimals to get you the better sense. Otherwise, it was appearing that all the portfolios have the risk of 8.65%. So if you notice, the one with the least variance is 8.6532 because all others are greater than this and it has 1.07% of return. So we will notice that on graph also. So if you come here carefully, it's like 8.66.1404, and if you slightly go up there would be 8.65107. This is a global minimum variance portfolio. At this point the variance is least. Okay, so and above this all are the portfolios are the efficient portfolios, so you can get uh, higher returns at the same level of risk if you're interested. But yeah, this is a global variance minimum variance portfolio. It's slightly lower than this. Yeah, this one. Hope you like the video. Please, if yes, please do share with your colleagues as well, and comment, share with your peers who are preparing for the exam. Thank you very much for watching. Stay connected.